Hi, this is Dr. Mary Hansen, and this presentation is on generating output for a simple linear regression analysis. In order to conduct simple linear regression, it is necessary that you have a data file that has at least two variables measured on the same subject. Recall in SPSS that each row represents a single subject. In this case, we have the data on two variables, impulse control and aggressiveness, for the same 7 subjects. In order to run a regression analysis, the goal should be to predict one variable from another. In this case, we want to predict aggressiveness from impulse control. In order to run a regression analysis, we click Analyze, Regression, Linear. The dependent variable, which is the variable that will be predicted, is aggressiveness. The independent variable in the study is the variable that we will be using to predict aggressiveness, which is impulse control. When we click on the Statistics tab, we want to make sure that we get estimates of the regression coefficients, so that box should be checked. We can get the model fit, we can get descriptive statistics, and then we can click on Continue. In order to evaluate the fit of the regression model, there are a couple of plots that you should investigate. These include a plot of the residuals versus the predicted values, in which case we're going to look at the standardized residuals as the Y data and the standardized predicted values as the X data. We're also going to get histograms and normal probability plots of the residuals. One of the assumptions in regression analysis is that the residuals, or the error terms, are normally distributed. These two pieces of information, the histogram and the normal probability plot, provide information about whether the residuals are normally distributed. Looking at the Save option, we could save additional columns of data, including the predicted values and the residuals, either standardized or unstandardized. For this particular analysis, I am not going to save additional columns of data, but this screen allows you to save a variety of measures of fit and other information related to regression analysis. Under the Options tab, we see options for a stepping method when more than one X variable is used. In our class, we will only be using simple linear regression, which is one X data, so we do not have to deal with the information in the Options tab. What we have so far is the dependent variable listed, the independent variable, or our X, or the variable that we want to use to predict aggressiveness, goes in under the independent variable. Under Statistics, we have asked for estimates, model fit, and descriptives. Under Plots, we have asked for a plot of the standardized residuals versus the standardized predicted values. We have asked for the histogram and normal probability plot of the residuals. And if I go ahead and click on OK, in my output screen, I get the output. First, I have descriptive statistics information on aggressiveness and impulse control. I get information about the correlation coefficient. The next piece of information that I will be considering is the table labeled coefficients, because it is in this table that I get the equation of the regression line. The impulse control row under the beta column gives me the slope of the regression line, and the constant, the row labeled constant, where the B coefficient is, of 14.487, gives me the intercept. I use these two coefficients in order to come up with the regression equation, which is y hat equals negative 0.834x plus 14.487. SPSS does not spit out the regression equation in an equation form for us, so it is necessary to get those two coefficients, the slope and the intercept from the coefficients table. Once we have the measures of the descriptive statistics and the regression equation, we can look at a couple of pieces of information to see the quality of the model. One of those pieces of information is the R-squared value, which is found in the model summary table. In this example, R-squared equals 0.752, indicating that 75% of the variation in our Y data, our aggressiveness scores, is predicted by the impulse control score or explained by the impulse control scores. So once I have the regression equation, the R-squared, I know the correlation coefficient. Now I have to assess the fit of the regression model. I do that in a variety of ways. First, I need to look to see if there's evidence that the residuals are normally distributed. Looking at this particular histogram, it doesn't appear that the residuals follow a direct normal distribution. I am going to also consider the normal probability plot. And in this plot, what I'm looking for is the data to fall right along the line that is plotted. In every normal probability plot, we will get a solid line plotted along the diagonal. And what we're looking for is our data to not have too much of a pattern and fall very close to that line. In this case, we see some differences between the data point and the line, but they are fairly small. So I'm not so concerned about the lack of normality in this data set. Given that I have a really small sample size of 7, I have some question about using regression analysis, but because this is an in-class example, we'll go ahead with 7 data points. Ideally for regression, we will have a larger data set. The last piece of information that we want to look at is a graph of the residuals versus the predicted values. And what we are looking for in this graph is just a random scatter of points. I don't see any pattern in this data, which means there is no pattern in my error terms. What we're looking for is to have a constant variance or a constant spread of the data, and I see that the data looks fairly spread out consistently in a random pattern in this graph. Therefore, I don't have any evidence that this model doesn't fit the data. I can go ahead and use my regression equation to predict the values of Y from a given X. Again, in order to generate the regression output, we used analyze, regression, linear. We plugged in the dependent and the independent variable. Under statistic, we asked for estimates, model fit, and descriptives. Under plots, we got a plot of the standardized residuals versus the standardized predicted values, denoted z-resid and z-prid. We got a histogram and a normal probability plot of the residuals. And that is the information that we use to generate the output for a simple linear regression. This presentation is by Dr. Mary Hansen.